Hi everyone, I'm Gyaji and I'll try to today I'm gonna do a math problem instead of gaming. So as I said, if I'm gonna name this series doing something until I get into my dream university, I should probably do something that is remotely useful. Anyway, let's do the first problem of the 2013 Bulgarian Mathematical Olympiad. I've never read this problem before. I mean, I've read it, but I've never even tried or thought about it. I just thought it looked cool. So let's try. Um, it is asking us to find all numbers p and q for which p times q plus 1 plus q times p plus 1 is a perfect square. So p times to the q plus 1 plus q to the p plus 1 is a perfect square. First things that comes to my mind, one of them is probably even. One of q plus 1 and p plus 1 because, well, 2 to the 3 plus 2 to the third is actually a solution. So 2 is a solution. Let's know that. But for now, let's assume that both p and q are greater or equal to 3. Then we get that both of them are even. So we can say that p to the q plus 1 is equal to n squared minus q to the p plus 1. And as this is even, we can factor this out as n plus q to the p plus 1 over 2 and n minus q to the p plus 1 over 2. Let's now note that this is a prime number, and if we multiply a prime power, and if we multiply two integers and get a prime power, then both of them are powers of that integer. So we get that n plus q to the p plus 1 over 2 is a prime power, a power of p, and same thing goes for the other one. In particular is q plus 1 minus x. And here we can see that x is greater than q plus 1 over 2, but I think it isn't that useful. So what do we do now? What I like to do here in these cases is, let's say this is equation 1 and this is equation 2. Let's try to compute 1 minus 2, and we get that 2 times q to the p plus 1 over 2 is equal to q p the q plus 1 minus x times p to the 2x minus q plus minus 1. This feels very wrong. Plus 1. Cool. Um, this sounds kind of awful. It isn't, because here we have a power of q. Like, there isn't any factor of p here, but here there is a factor of p. So either q plus 1 minus x is equal to 0, but in that case, we'll do that case later. So let's assume that q to the p plus 1 minus 2 is greater than n plus 1. So if this isn't equal to 0, then here we have a factor of p, and here there isn't because p is greater than or equal than 3. And here, the only way that this is possible is if q and p are equal. So hence, if x is less than q plus 1, we get that p is equal to q. If p is equal to 2, if p is equal to q, we simply get 2 times p to the q plus 1 is equal to n squared. And here we can clearly see this is actually p plus 1. That 2 divides the left hand side, so 2 also divide the right hand side, and then 4 divides the right hand side, because if 2 divides a square, also 4 divides that, so 4 divides this, so p is equal to 2. Therefore, the only solution for p equals to q is 2. The only case we have to check yet is if what happens, here we can actually just assume that p is greater than or equal to 3. Yeah. Because I've never used the fact that q was greater or equal to 3. So now let's just check what happens if x is equal to q plus 1. Let's go here. We then have that n plus q to the p plus 1 over 2 is equal to p to the q plus 1, and n minus q to the p plus 1 over 2 is equal to 1. This gives us that n is q to the p plus 1 over 2 minus plus 1. Substituting this here, something we will do very brutally, just like this, we get this fine equation. So 2 times q to the p plus 1 over 2 is equal to p to the q plus 1. And I feel like this is just a problem with bound plus 1. Okay. Well. What do we do here? Okay. At this point, let's also assume that q is greater or equal to 3. And let's bring this one to the other side. And let's factor this out. We get p to the q plus 1 over 2 minus 1. And p to the q plus 1 over 2 plus 1. And this is equal to 2 times q, that thing. We now see that here there is only 1 power of 2, and there should be 2. Yeah, in fact, I do not even have to do this, actually. Let's go back a little. We had this at some point. Here we can clearly see that this is congruent to wait, what? Why doesn't this work? You know what, never mind. Strange. Okay, here. Um, if q is greater or equal to 3, this is even. Okay. And in fact it is congruent to 1 modulo 4, because a number greater or equal to 3 raised to an even like a prime raised to a even power modulo 4 gives 1, and here if we do -1, we get something that is congruent to 0. Hence this side is congruent to 0 modulo 4, but this isn't, as q is greater or equal to 3, and there is only a factor of 2 over here. Therefore, if p is greater or equal to 3 and q is greater or equal to 3, there are no solutions. We have already done the case where both q and p are equal to true. Hence, we only need to do one case when either one of them is equal to 2. Without loss of generality, let's assume that p is d1 equal to 2. We then get that we have to solve this equation. Q to the third is equal to n squared. Same thing as before. Take this, bring it here. Let's factor this thing out. 2 to the q plus 1 over 2, and to the 2 times q plus 1 over 2. And here there are only two options. Either this is q squared and this is q, or this is equal to q to the third or n1, because this is a prime power, and hence both of these have to be a prime power, and this is clearly larger than this other one. So these are the two cases. We shall now check them manually. This is a long problem, but quite easy. Very routine-like. And as in the competition, you have 4 hours and a half. This should be pretty easy. Let's start with this case. We get that n to the 2 to the q plus 1 over 2 equal to q squared, and to the minus 2 to the q plus 1 over 2 is equal to 2q. Here we can either add them up or subtract them. I would rather subtract them. So let's do 1 minus 2, and we get 2 to the q plus 3 over 2. This should be right. Yeah. Okay, I'm convinced. And on the left hand side, we get q to the times q minus 1. Let's know that q divides this, divides the right hand side, so q divides the left hand side. Therefore, q divides 2, hence q is equal to 2. And we go back to the same case as we did before. So we only need to check the last case. This is equal to q to the third, and this is equal to 1. So, and plus 2 to the q plus 1 over 2 is equal to q squared, and plus... I just realized that these cases we can simply do with sound bounding. Like, we can clearly see that for q greater or equal to 7, maybe? Something like that. No, a little bit more. Like 20 for sure. the left hand side is way bigger, because here there is an exponential, something like e to the x, while on the other hand we have x to the n, which is much slower. My bad. Okay. Well, this isn't very... This is also a way of solving it, but we would have to check many cases by hand, and we do not really want to do that. So, let's now see that this tells us that n is equal to 2 to the q plus 1 over 2 plus 1. Substituting this here, again, I know, crazy, and factoring things out, we get this equation. And if we wanted to overkill this problem, we would say by Mihailescu. That is a math theorem that solves the equation of this kind, that says that the only solution a, b, x, y, if x and y greater than 1 is 2, my bad, 3 to 3. But this is way overkill. We do not need this. One way of solving this is you bring this here, change the sign, and get q to the third minus 1 is 2 to the q plus 3 over 2. That is just... never mind, just bring the 1 on the other side of the equation, and you get that q minus 1 q squared plus q plus 1 is equal to a power of 2. Therefore q minus 1 is a power of 2, and so is these. Am I actually gonna use Mihailescu here? Well, here one thing you could do is say this is a power of 2, this is another power of 2, and do the same thing that I've done throughout the whole problem, by the way. But there is this theorem that I said before, that I've stated before, that tells us that there aren't any solution of this kind. Again, another way of solving it is saying that for q greater than a number n, which is less than 30, there are no solutions for bounding reason. So yeah, we have done the problem. The only solution should be 2, 2. Very good problem. I indeed liked it. Let's see what the solution from art of problem solving is. Yeah, I feel like people have done kind of the same thing. Yeah, so this is the only solution. We've done it. It went pretty good, fortunately. I have no idea how long this video was. Something like 20 minutes, maybe. Consider that I've never seen this problem before. I wanted to show you my way of reasoning, even though I'm not that good, but I feel like it could be useful and entertaining, maybe. If you liked it, let me know. If there are any problems you want me to try, tell me in the comments. Um, anything you really wanna tell me, write it in the comments. I really enjoyed doing this video, and see you tomorrow. As always, stay hydrated. I love you, and see you tomorrow with maybe another problem. Not sure. Bye.